Okay, so the goal today is to finally look at the actual SeedSigner code and do a high level overview of how it's structured, why it's structured that way, and basically just where pieces are so that, I know Marc here, who, by the way, you should introduce yourself real quickly. Marc is a phantom voice because he's keeping his OPSEC secure. So Marc, you want to say hi?
Hi, I'll be the voice from the sky, as Keith likes to call me, and been following the SeedSigner project for, I don't know, probably about 8 or 9 months now. And although Keith has had an amazingly busy weekend on other aspects of SeedSigner, today we're going to have a look at them. I'm really excited to get stuck into the Python code.
All right, and we did a couple streams leading up to this where we went through manually installing the code, so just following the build instructions on the GitHub repo. And then we also did a session on, I'm already blanking. What did we do after setting up the code?
After setting up the code, we did some basic stuff on pull requests, and we did the rsync configuration, and actually pulling down so the first session we set up the dev environment with all of the repositories that it needed, and then the second time was setting up Visual Studio, IDE, and rsync. And right. I had some extra stuff on that because I was running from a Windows environment with WSL2, and so there was some interesting stuff on that. And I've made some notes, which I'll soon be publishing.
Good. So we'll help people on Windows follow the same steps. So roughly it was set up your Raspberry Pi, your Pi Zero, to work for local dev, and then setting up your environment where you're going to be actually making the code changes, which in my case is my laptop. We're looking at my MacBook screen right now, and it is connected to my development SeedSigner. Okay, so now we can finally look at the code. So,
yay!
The most basic thing is the code enters at main.py, and all it does is instantiate our controller object, and it tells it to start. So if we look at our definition of our controller, and I'll be doing a bunch of jumping around because, it's actually, let me take a step back. This is where I wanted to start. So let me make this bigger. Okay, so hide some of this. There we go. So, and I'll hide my other stuff. There we go. The core design philosophy of how SeedSigner is organized is that it mimics a web-like environment. So, we are not writing web pages. You're not surfing the web on your SeedSigner, but the code is organized around similar principles as a web server, for example, is organized around. So for just the web level, this is what people are used to using. The way that the web works is you send a request to a website, and then it processes your request and it sends you back a response. So your request might be, hey, just load the seedsigner.com website. And the response is all of the content that determines the website, the HTML, the CSS, the image resources, whatever. That comes back to you in the response. So under the hood, there's a web server that's listening for those requests, processing them, and then sending back the response to each person. So this is all very simple. It's like web, 101. And if you're a Python programmer, chances are you've worked with either Django or Flask, and those are frameworks to provide web server, Python-based web servers. And so in the response, you get things like HTML and CSS coming back. In the Flask world, you'd be writing a Jinja template, which just dynamically creates HTML and CSS. And then the actual things that you see on screen are defined by, at kind of the most base layer, core HTML objects that are just built into HTML. Like, you don't have to tell HTML what a button is. It already knows. It knows what an image is. It knows what input boxes are. And then it's up to your browser to render those elements to display them to you. Okay, so all of that being said, in the SeedSigner world, and here's our highlighted SeedSigner row, we have what's called the controller. So this is analogous to our web server in the web world. And whatever context we're in, whether we're on the web or we're in SeedSigner, the goal of this column, the controller or the web server column, is to manage the overall state. So like if I log into a website, it remembers that I'm logged into it and it can retrieve my account data. Or if I'm in the middle of checking out, it knows like, oh, Keith has these items in his cart and he's put in his billing address, but he hasn't put in his credit card yet. So it just manages these flows from task to task. So same thing in the SeedSigner, the controller's job is to manage overall state and to route across these tasks through these flows. In the Django or Flask world, you build what's called view objects, and they handle requests. So these incoming requests are either going to be, a get, which is just say, give me this web page, or a post, which is when you send data to the web page. So when you log into a web page, you're posting your login credentials to that website. And all that logic is handled in the view. So, and we use the same terminology in the SeedSigner world. A view is where we handle retrieving data in order to show it back to you, processing any new data, like, I said, if you log into a website, you're sending your username and password. In our case, we might be loading a seed and typing in the passphrase for the seed. So that'd be new data that we're introducing into the system, and enforce what are called business rules. On a website, it might be, if you're not logged in, the view won't let you see, account data, because there's no account data to retrieve if you're not logged in yet. And similarly for SeedSigner, if you're viewing the seeds screen, if you don't have any seeds loaded, it won't show you anything, right? So the behavior might change depending on the context that you're in, and the views are savvy about that context. They can custom craft the information that they're either sending or receiving based on where things are at. So these are really these first two columns are really the brains of the system. The controller is what it sounds like. It's controlling and managing everything. And then the view is making page by page decisions about what to show or what to ask for. Then we get to the dumb layers, the screen or the HTML and CSS. This is just displaying the end result, right? It's once we've prepared your response, it just has to render it into some visual format. And so for SeedSigner, the screens are really dumb. All they do is they format and present the data, or they accept your new user input. So, a view might be enter your seed passphrase now, and the screen that goes with it will be the keyboard UI for you to type it in. And then this last column, or this next column rather, is in HTML, we have these object primitives that display elements on screen that are just built into HTML. And in SeedSigner, we have UI primitives called components that are reusable UI elements for presenting or inputting data. And so very analogous, like there's a button component for when you need to be able to select and click something. And so we'll have a look at some of those components. And so a series of components would be used to build up a screen. And then we have a renderer class that actually figures out, okay, I know that you want to draw a button on your screen. What are the actual pixels of the button? How do I render the actual text and all that? And so this is the thing that actually paints pixels to the SeedSigner display, just like your browser takes the HTML, interprets it, and then renders it to your screen. Let me pause there. There was a lot there. Hopefully the web layer sounded reasonably familiar. But any questions so far?
No, I think that's pretty clear. I like the description of the view, where that is both a display and accept data, but it's, I would imagine, almost mostly to deal with the business logic and then produce the flow for the various screens. So even though it's called a view, it's not for viewing.
Right. Yeah. Yeah. And this terminology, it's a holdover from the web server world where you have model view controller, and we'll look at some models, but basically there's view, there's controller, we'll get to models. So it's this MVC paradigm, and view has always been kind of awkwardly named in that model view controller paradigm, but it's really just carried over here for familiarity for somebody who's done work in Flask. They'll know exactly what a view is as soon as you say it. I will keep referring back to this just to keep us rooted in like which column we're looking at in the code. But yeah, so for now, let's take a quick look at the controller. Although the controller is a little more complicated than I'd like to get into too deeply right now. But anyway, so here's our controller object. And then just to show you where we're at, we're in source SeedSigner controller.py. And so the controller, it's just kind of like some basic stuff, like get access to the buttons. We have some storage here is a misnomer. This is just our in-memory data storage that will be deleted when the SeedSigner is turned off. We have a settings object, which really should be a whole other live stream that we do. The settings world gets very deep. And then the renderer, so that the code can draw itself. And then we just have a bunch of frankly, random crap that we had to throw in somewhere. And I don't love that a lot of these things are just sitting here. But, just like your web server has to have some record of who's logged in, what's the state of their shopping cart, all that stuff. These are really the state variables. If I've scanned in a PSBT, it gets stored here. And then when I select which seed I want to sign the PSBT with, that seed gets temporarily stored here. It's just that we need a place to park this information, and the controller is the one main central hub. So it makes the most sense to park that data there. But as you see, I've got a bunch of to-dos because it's this is not the prettiest way to do it. But anyway, this is just setting up our controller. What really matters is we have this start function within the controller, and this is where all the real work happens. You can kind of see a preview here. Here's the opening splash screen. It instantiates the opening splash that shows our logo and the version number. And then it says, hey, start, right? Render your animated sequence of showing the splash screen. And then the real meat of it is we do an infinite loop while true. We keep looping where we retrieve our next destination, whatever that means. We'll get to it, and we tell that next destination to run itself. And so this is basically our request response cycle. And for now, that's as far as I want to get into the controller. So what I really want to do, let me bring back my SeedSigner. What I really want to do is look at like a simple page. Like if we click into tools. So as we said here, the view column, a view is associated with a request. So it's equivalent to a request in the HTML world, in the web server world. So the way you can think of it as each screen on the SeedSigner, each page of the screen of the SeedSigner UI has a view defining its behavior and its look and everything else. So if we go to SeedSigner views, and let me make this a little bit bigger, we have a whole bunch of different categories of views here, and I'll look at tools views. And so here's our tools menu view, which is exactly what we're looking at on my SeedSigner screen right now. You can see we're setting up an option for an image that says, hey, new seed. That's the camera icon plus, so camera icon plus the text, new seed. We've got the dice icon plus the text, new seed. And then we've got a keyboard icon and the calc 12th/24th word text. So that is all how this simple option screen is being assembled. So it just has those three selection options. So we're assembling those three options into just a simple list called button data. So it's just the list has three things in it: the image option, the dice option, the keyboard option. And we're going to feed this button list into a button list screen element. And it shouldn't be too surprising. We're in a view now. The view is creating a screen. The screen is to format and present the data. Okay? So the button list screen, it's a very generic name because this button list, wake up SeedSigner, we have lists like this all throughout the UI over and over again, right? So it would be dumb to write specific code just for this tools menu view to render a list of buttons, when, I don't know, 40 other screens need it. So, in Python, the mantra is don't repeat yourself. And so anytime we can reuse an element, we set it up to be generic and reusable. And so this button list screen that we're looking at right now, it has a title. The title is tools. We can see that on my SeedSigner right now. Is button text centered? It has a whole bunch of options that we can configure on this button list screen. So if I hover over it, there's all these possible inputs that I can pass into this screen. For the most part, it has typical defaults, so I don't need to configure everything on here, but I can customize it to do what I need it to do in certain other cases. The button text is not centered. That means it's left justified. And then here's the button data. It's these three elements that I want fed into the screen. So let's look at the definition of the button list screen. So now where are we? Now we are in SeedSigner GUI screens.screen.py. And so this naming convention should tell you this is the most generic, most base collection of classes for the entire screen universe. And again, we are now at the screen-wide rendering layer. We are preparing a screen to display to the user. So the button list screen is derived from something called a base top nav screen. So we're gonna have to kind of crawl through the hierarchy here. So the top nav is this bar at the top of the SeedSigner that says tools, and it has this this back arrow. All right, so that's our top nav. It's basically a title bar with a back arrow wired up to it. So the base top nav screen, and again, anything that says base tells you that this is a generic parent class that isn't meant to do anything on its own. You're just meant to derive child classes from these bases. So this base top nav screen was used to derive our ButtonListScreen. So not surprisingly, in the base top nav screen, it has to create the top nav. So the top nav is our first foray into a component. So a component is just one chunk of functionality that appears on the screen, one visual element that appears on the screen. So our first component is a top nav object. So if we go dive into that, now where are we? We're in GUI components. So shouldn't be surprising, given our naming convention here. And also shouldn't be surprising, our top nav component, and again, this is just this top bar, is derived from a base component itself. But let's hold off on that for now. So the top nav, it has some text that it displays up top. It's got a background color, which defaults to black. It has some optional icons that we can throw in there, like for the when you click on a seed that you have in memory, I think there's a fingerprint icon at the top in the top nav. And then we have options to show the back button. This is almost always active. And then there's also a power button. So if we look back, if I go back to the home screen, there's a power button up there. So this is still a top nav object up there. I just don't have the back button enabled, but I do have the power button enabled. Okay. And so in order to create my top nav, it consists of the left side button is the back button. And so it's going to instantiate another component, which is an icon button. And the icon button is just a type of button that can display an icon. And in this case, it's the large chevron left. So that's the left arrow to go back for our back button. So we've created our back button instance. If we're going to show the power button, we create another icon button and we give it the power off icon. But in our case right now, that's hidden. And then if we have an icon that shows up on the in the title, but if we don't, we just have our title, which is a text area that has the text, the title text that we pass in. And text area is another UI component defined in SeedSigner. So we're not going to go into all these individual components. Like text area gets really complicated because it does things like line breaks, auto resizing, that sort of thing. But this is a really trivial use of the text area because it's just spitting tools up top. And then there's some logic to keep track of, like, you know, which buttons are selected. And then when we need to render, we render our title and we tell the buttons to render themselves. But so all of this is just to draw the top nav. So it you know, as you walk through this hierarchy, it seems like a lot of work, but you have to remember we didn't have any sort of UI layer, advanced UI layer library to work off of. So like if we look at how to create this button, the most help that we got, and it is derived from button, So here's our button class. I'm going to skip a bunch of things. When we render a button, okay, we're literally saying, hey, draw a rounded rectangle. And if there's text, write the text using, this font, this color in this position. And so, if you look at like all of this, like just to draw the text, basically I have to calculate, okay, I know where the button is supposed to be rendered on screen, but where does the text belong on screen inside that button? And so there's the screen x coordinate plus the for the button plus the text x coordinate, because if we look at where the text starts, it doesn't start at the same x coordinate as the button does. It's indented in. And so there's just a lot of crazy work to just position things that, you wouldn't really expect. But the nice thing is, if this feels overwhelming, well, be glad that there's a button class, right? So I've done all of that work to size and position things in theory so that you don't have to, right? You can just, by the time we get to trying to instantiate our icon button or our top nav, I'm not worrying so much about all those positionings. I'm just saying, hey, just give me a text area. And yeah, it's located at this X and Y. I set some parameters on it. And then the text area figures out all this stuff for us and renders. So this was our first like super deep rabbit hole dive. And just to back up again, so we're setting up a screen that's built out of individual components like the top nav. And the top nav itself is built up from reusable components like a button, like a text area. Let me pause here. How are we doing?
I'm doing well, able to follow. And I guess what I'm also really seeing is that the components themselves, you had to build those because they didn't exist.
Exactly.
The text box example that you have is here's the beginning of a text box, whereas in a whole lot of other environments, that object exists. It fundamentally understands that the font is going to start a little bit to the left or to the right of the edge of the box, and the overlap of the text and the box, all of that you had to actually build. Now, as a beginner, we don't have to worry about that. It exists. We call that class, and it will then render that button for us and deal with where the text starts and where the icon sits next to it.
Yeah, and I said within reason because they're not bulletproof against every possible thing you could throw at them. They're just more than good enough for what we needed them to do. But then things like doing the multi-language translations, different languages have different, just different demands on the UI.
Absolutely. The kerning between the fonts is going to be different, all of those aspects. And I think we have to also just keep in mind that every component, even if you purchased a component for your application, that component has got limitations too.
Right. Well, an out-of-the-box solution will definitely be more bulletproof than my components here. But my components are good enough for now. But yeah, so
good enough for now. They've worked well.
Right. So for example, within text area, I've got this description that says we have to figure out if and where to make line breaks in the text. And so again, I'm not going to dig into all the details, but it's kind of absurd. I actually had to write a recursive binary search to decide how to fit the text in the box, which is like, when I realized it should be a recursive function, I was just like, oh my God, this is never going to work. But it seems to have mostly worked. But then there are things like, look, I literally have a text does not fit exception. So there were cases where, hey, you know what? I tried to make it fit. I couldn't. And rather than, make things even more complicated, I just throw an error. And then the idea is that the coder who's trying to build this page would see this error get triggered and be like, okay, either I need to make the text smaller or I need to redesign the screen, change what information I'm showing, whatever. So we do have limitations in here, but yeah, I am astonished that I got this recursive binary search to work to figure out where the line breaks go. But yeah, exactly. Like for HTML, you don't have to worry about calculating, how to reflow text given how wide your display window is, right? You get that for free in HTML. It just works.
Yeah. Between the browser and HTML, they figure out what the machine's screen resolution is, and it'll reflow the objects and the text inside of them to the necessary size.
Yeah, exactly.
With exceptions. So well done.
Okay, so again, this is all a long journey through like kind of a fairly deep component structure. So just this key idea that you can almost think of top nav as a meta component, because it's a GUI component that consists of multiple other child components like buttons, like text areas. But now that the top nav has been defined as a GUI component, I can just instantiate it as a GUI object to include in my screen. So now we're back at our base top nav screen. So this is going to be a reusable screen that has a top nav element to it, and it doesn't care what the screen is for. It doesn't matter. Like literally the default title is screen title, right? Because this is just a base class of a screen to display anything that needs a top nav, which is basically
designed to be reusable.
Right. And not just reusable, but designed to never run by itself. Like basically, if something is called base, usually that's, you can, I don't think Python has the same notion of abstract base classes in the way that like Java or I think C++ does, but it's essentially an abstract base class where you're not meant to ever run a base top nav screen as is. You're only meant to do what I showed over here. Let's see, where is it? Like ButtonListScreen is an implementation class that's derived from this abstract base class. So
got it.
So in our going, pulling all the way back to our view layer, and again, we're just staring at this really simple tools menu view. It is instantiating the button list screen. The button list screen is an implementation class that's built on top of the base top nav screen. And as you'll find, I'm a stickler for clarity in my naming conventions. So I don't abbreviate anything. And there's some absurd class names because of that. But like it's a screen that is a base class that exists to provide a top nav. And so it is a base top nav screen. That is what it is called. This is a thread that provides the loading screen, so like on and on. You can see like I'm pretty slavish to this like very declarative naming convention. Okay, so here, large button screen. Guess what it does? That's the home page. The home page has large buttons as opposed to these smaller standard buttons. And on and on. But anyway, within the button list screen, So that entire tangent, just to say that we now have a top nav in here. And in order to specify, let's see, the title of our top nav, actually this bears stating also. Some people may be a little unfamiliar with this kind of class format where these are called data classes. So what's nice about a data class is, like, normally in Python, you would do something like def, init, self, and then, var1, oops, var2, var3. So those are your inputs into this class. And then the first thing you would do is self.var1 is var1. Self.var2 is var2. Self.var3 is var3. Right, so it's really annoying. You just have this boilerplate in traditional Python classes where you're just taking inputs and then you're storing them onto the object you're instantiating. It really sucks to have that much redundant code. And, like here we've got, 6 input variables to this class. But if we keep looking, this one has all of those original 6, plus some extras, or some of these are overrides. And, just as you go through, there's just way too many input variables to keep writing the stupid boilerplate for. So the beauty of data classes is we get rid of all of that, and we just declare the input variables right up top this way. And they automatically get mapped to the same value in the when you instantiate the class. So, like, I don't have to tell it to store title anywhere. I can just immediately refer to it as self.title. It's automatically copying this title input into the object itself that's within this defined by this base top nav screen.
Yeah, that makes perfect sense. And I guess the only thing that I was maybe initially thrown by was from other programming languages, we might have declared that with CLS in its name so that you knew that it was a class. But otherwise, the concept of classes and then referring back to those so that we have that maximum amount of reuse is all 100%.
Yeah, sorry. Keep coughing. And then for data classes, because you don't need that init method anymore, there's a newer post init where you can take it as a given that all those input variables have been set. But if you have other setup tasks to do whenever you instantiate the object, they go in the post init. And then, so, like, let's see. So title is one of the inputs for our base top nav screen. If we look at our button list screen, it doesn't even mention taking title as an input here. But because it inherits from base top nav screen, title is automatically assumed to be one of the inputs to button list screen. And so if we look at when I instantiate this, I'm giving it a title. I'm saying, hey, your title is tools. But if you look at the button list screen, there's no mention of title as an input. You have to go back to its parent to see, oh, the parent took title as an input. And then even further back, there's a base screen, which actually has no inputs. So, but anyway, if you have a hard time tracking down where is an input variable declared, just trace back through the inheritance hierarchy. But it's nice because, if we hover over this button list screen, I showed you this before, there's all these possible input variables that we can set when we instantiate this thing. But just because of the way the inheritance works for the data classes, I only have to show you either the new fields that are important, or sorry, let me go to the button list. So here I'm only going to show you the new fields that are important, like button data is my list of items that are going to show up as buttons. So these three options in my tools menu. So that's new for ButtonListScreen, right? The base top nav screen doesn't know anything about what button data is. So this is a new requirement for button list, but I don't have to repeat this whole list unless I have a reason to. So like, and then because there's everything has a sane default, unless you're doing something special, the defaults just do what you want them to do. Like, yeah, I don't want to see the power button except on the one home screen. And yeah, I will always want the back button unless I have a really weird page. Actually, I don't know if we've ever, yeah, we do disable the back button on a few, in a few certain cases. All right.
Yeah, but I mean, like the font name and the font size and the color and all of that, that's defaulted in, and that's how it's going to be.
Right, right. Okay, so our button list screen has our list of buttons that it's going to render. And I don't want to get too bogged down in these details, but let's see. What is interesting here? Actually, let me follow. Where is the button list data? Okay, let's see. There we go. So now we're iterating through all of our buttons, all of our button content. So in this case, the three buttons that we want to identify, that we want to display on our tools menu. So for each button label, like new seed or calc 12th, 24th word, we are going to, well, we're setting up some button data and just trying to review what is going on. So, I mean, look, this is why we have reusable classes, because you don't want to have to define all of this work just to figure out how to draw a freaking list of buttons. Like here's some important work that this button list is doing. It's incrementing the Y position for each new button, because otherwise they would draw on top of each other, right? So something as simple as that, saying, hey, you know what? Don't draw them right in the same place. Shift them down by, whatever amount. So this is the ith button is going to be shifted by the height of the button plus some default padding pixel space.
And Keith, that's because list itself is not actually a class. So it doesn't have that change the y-axis inherently in it.
Well, I mean, this is it, right? This is the GUI component that's going to give us a button list. And so this is where, or I'm sorry, you're right. I could have, I'm getting myself confused actually. So if we go to components, let's take a look at what's in components. Let me shrink this. So we have fonts, we have a base component, text area, icon text line, blah, 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 button, top nav, and that's it. So yeah, you're right. There is no button list component that I could just instantiate here. Which, maybe that was a miss. Maybe I should have defined it. Although I think I didn't define a button list component because the button list screen is the only place that would ever use it.
Right. That makes sense. Besides which, version +1 is always better than, that. There's always more to do. There's always, I just want to point out that, there's always hindsight is 20/20 vision, and maybe that's different. But as you point out, if it's only used in one place, why bother with creating a class?
Right. And so so the whole reason we're iterating through the list of buttons here is because we're literally going to create a list of button objects, and we're going to store it in a buttons variable. So somewhere in here, I don't know why I'm having a hard time finding it. Somewhere in here, we're actually going to instantiate a button. Oh, there we go. So depending on which kind of button it is, either instantiate a large icon button like the home page, or instantiate a regular button. And so, yeah, okay, now I'm remembering. Yeah, we're setting up all the arguments to create the button. And then if it's one of these large icon buttons, they have some extra data that need to get set up. And then we can pass these button arguments in, or we can just say, okay, instantiate our button, and then we save it to our buttons list. And then the screen has a run function. So something as simple as, like, when I navigate around this screen, it changes which button is selected. But just to make that happen, we have to have a loop going in the background waiting for user input, so it can detect when the joystick is being pushed up or down or when it's being clicked in. And then the screen itself has to re-render because a different button has been selected. And so all of that logic is basically happening in the run class, where, you know, like while true, like as long as the screen is running, we're always going to be listening for joystick input. And here's our hardware input, so the joystick. Wait for, so if you press up, down, left, right, or any click button, we're waiting for user input. So nothing is going to happen until we get some user input. So right now, the code is just infinitely looping, or it's inside this wait for. It's infinitely checking. Did somebody press one of these buttons? Did somebody press one of these buttons? Did somebody press one of these buttons? Over and over again. And then when it finally gets an input, whichever it is, up, down, or click, then it says, okay, we got an input. So now, if the input was key up, okay, up. But then we have to handle it. So again, all this stuff, I won't go through all the painful details, but if I'm on this new seed, the top item in my list here, and let me go to my webcam view. If I press up from here, I'm going to leave my button list and I'm going to enter the top nav. And so the top nav needs to be aware that my joystick movement has entered the top nav, and it needs to redraw itself because now it needs to highlight that back button. But then if I press down from the top nav, it has to alert the button list screen, like, hey, you've got the ball now. So you need to update and you need to render your button. And then I press down and then I press down. But then if I'm at the bottom of the list and I keep pressing down, nothing happens because there's nowhere else to go. So all these things are like there's nothing shocking about any of this. But all of that logic had to actually be coded in, because again, we don't get any of this for free in the SeedSigner code. So like literally that's all the stuff that's going on here. Like if we have to move up to the top nav, hey, top nav is selected, true, top nav, you need to redraw yourself, re-render your buttons. And, you know, so it's just all this stuff. So all this code, all these if statements are just to handle all the scenarios that could happen just by navigating up and down in this list.
Because it's waiting for input the entire time. And so it is just looping through, waiting for that input, and then we'll redraw the screen appropriately.
Yeah. And so like, you know, if we moved, let's say we moved down and a new one of our buttons is now selected. So we we store it. We say, hey, you're selected now. And so, hey, you need to redraw yourself. And so that's how we get the new button to light up. But it's all just ridiculously manual and kind of terrible. So yeah, so I mean, this is like really like deep down nitty gritty stuff that, you know, it was a pain in the ass to write. I'm glad it's done. I don't ever want to rewrite that again.
Agree. I have one side question. What is a kwarg? There's an aspect in the class called a button kwarg.
Yeah, so the easiest way to display that is by this example down here. So we're collecting the input arguments to create the next button. So this is in our setup for the button list screen. So things like, okay, what's the label on the button? Where is it positioned? How big is it? You know, blah, 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 font, you know, color, etc. So this is all being set up as a dictionary object. So same as JSON. So key value pairs.
Yep.
And what's important is that the keys are an exact match for the input options on the button class. Text, screen X, screen Y, width, height, whatever. And so that means that we can pass this dictionary straight into our button constructor. And it will know how to read these variables. It will know how to read them as variables because the names match perfectly. Like, is text centered is right there. Right, so there's a perfect match for the variables that we want to set on the button. And then this ** notation just means, hey, don't pass it as this giant dictionary, blow it apart so that so when this comes in, let me do this. I won't do the full thing, but this ** button args is equivalent to saying, instantiate this as text equals button label. Screen X equals button start X. And so it's just exploding this dictionary,
entire dictionary into
this format.
The variables.
Yeah.
And the in the dictionary definition, those tuples, they match the variable names, or does it do it based on the sequence?
No, it's just it's all named arguments. So font name is font name. So if we pass in something that doesn't exist, you know,
got it.
Foo bar, the button class will have no idea what to do with this named argument, and I think it'll throw an error.
Okay. What is I see now that args is in the name. What does KW mean?
So let's see.
Is there a funny story to that?
No, it's just it's so args are the
the arguments.
Yeah, it's hard to I'm trying to find a better example. Yeah, let's use something like this. So regardless of what this function does, it's just some function, right? So the args, actually, let me go back. Let me do it this way. Okay, let's see. Let's go here. So when I'm instantiating my screen, my button list screen, I'm saying, hey, the argument named title, pass it in as tools. If I were to look at button list screen and its definition, and also keeping in mind that its parent classes, there is an order here that these arguments are declared in. And so in theory, I don't have to say which argument is which, you know, like a programming language like C would call a function like this. Like you don't give the arguments a name. You just say, hey, argument 1 is tools, argument 3, 1 is tools, 2 is false, 3 is button data. But so if I don't give them a name, these are just the args. But if I give them a name, they are the kwargs. And I don't know what the maybe it's like, I just think of them as the named arguments. But I actually don't know the etymology of kwargs. Maybe it's like known args. That'd be a weird.
Right. Okay. Yeah, that could work.
But yeah, but then that's just that's the difference. That if I could say like, hey, there's a variable foo, there's a variable bar, so these are my args going in, and these are my named kwargs. Yeah, people who know Python better than me can tell me how wrong I am about my understanding of certain things.
Apparently, they'd also tell us, and I was learning about this yesterday, that foo and bar are not the nomenclature used in Python. We have to use a Monty Python comic.
Oh, I didn't know that.
And I think it's speck and eggs.
I've never seen that.
Yeah, it came up in Wikipedia when I was looking at it yesterday.
Okay. All right, so we've got our button list screen. In the run, we're managing our user input loop to handle like our joystick actions and repainting the screen when we need to.
Yep.
And then if I finally made a selection, it's very simple. I just exit my screen and I return the selected button. So maybe it's, button 0, maybe it's button 1, maybe it's button 2. I return that button to my view. And so this whole time, my tools menu view has been waiting while my screen displayed itself. So just like that hardware wait for that's waiting for user input, my tools menu view, when it instantiates its screen and it tells the screen to display itself, this view will now just sit here and wait until display returns. Oh, S10SBTC. Kwargs is keyword arguments. That totally makes sense. Thank you.
Yeah.
That totally makes sense.
Nice.
Yeah.
Keyword arguments. Excellent.
Kwargs, it's a cool, weird sounding term.
Yeah.
Okay, so but anyway, my view, which is right here, my tools menu view, is just waiting for the display to return. And it's going to return my selected menu number. So I've got these 3 buttons in my menu, plus the back button are my possible returns. And so then we just have a big if statement here. If it's the back button, which has its own special return code, then our next destination will be to pull from the back stack. The back stack is basically your history, your SeedSigner navigation history, with some limits. If I selected image entropy, then our next destination is the first view for the image entropy. And, I said my naming convention, we're in the tools section of the code. The user selected image entropy. And the first thing it does is it opens up a live preview. And of course, that's all managed by a view object. So that's how you end up with tools, image, entropy, live, preview, view. Okay.
Tools, image, entropy, live, preview, view. Okay.
Because that is the starting point for. And actually, let me do it on my SeedSigner. So if I select.
Oh yes,
image
entropy, got a DAS entropy.
There we go. So the first thing it did was it opened up a live preview. Right? That the purpose of this view is to give us a live preview for our image entropy. So the name is very descriptive. If we were to select the dice entry, we would go to Tools, Dice Entropy, Mnemonic Length, View. So what do you predict the screen will ask for?
Do you want 12 or 24?
So here we go. Yep, 12 or 24 words, because that determines how many roles it needs to expect. And then the last option is the keyboard entry, where you're going to pick your final word. The next destination would be Tools, Calc, Final Word, Num Words View. And so same thing. It's if we go to that one, it's going to ask 12 words or 24 words in your mnemonic. How many words are you about to start typing in on your keyboard here? Okay, so now we're getting, we've gone through the hardest, deepest muck, right? The UI, the screens and the components are the deepest, most complicated parts of the SeedSigner code, because all of it is custom, right? Like we said, all of that micro positioning at an individual pixel value, and then handling the UI logic of, down, down, now I'm stuck, up, go to the top nav, down, back into my list. All that's can you imagine, so all that had to be custom coded. Imagine the keyboard. Okay, the amount of custom code to get this keyboard. So, okay, I picked my first letter. Okay, letters drop out of the keyboard. And when I navigate, nothing happens. But then if I go over one of the letters, okay, now it starts auto-completing, right? Like, the keyboard is all custom coded. Just, oh my God, so hard.
Wow. I never realized that even the keyboard, because the keyboard, even to enter a new word, so the keyboard, the A to Z, you had to code that too.
Yeah, so we'll take a short diversion into the keyboard. It's not even in the components file because it's so big. I pulled it off into its own GUI Python file. So the keyboard, first of all, it's not bad. 625 lines of code. That's actually pretty slim. The keyboard class contains within it a class for each individual key. So it's a child class that represents a single key, right? Like, hey, which letter are you, right? And then which keyboard do you belong to? Where on the screen do I draw you? And are you active? Is it selected? Selected is different from active because, like we saw for the mnemonic phrase entry, we deactivate letters once the autocomplete logic starts taking over. So if you pick Z, there's no BIP39 word that has another Z after the first Z. So we deactivate Z from that point forward. Render a single key. The key has to know how to render itself. So on and on.
This is huge. I'm just scrolling through the 600 lines here and seeing where we're literally defining the alphabet.
Yeah.
In there. Just a side note. Is there? This is a very specific keyboard, so we could probably not imagine that a component would exist. And I just think, we just have to recognize that this kind of selecting words from a pre-existing list like that it's pretty unique functionality.
Yeah, and that was the very early keyboard was one of my first SeedSigner pull requests, one of the first new features that I added. It might have been the first. I can't recall now. But yeah, let's follow that through. So we'll get to the keyboard in a couple minutes. So let's say that we did say, hey, I want to type in my my mnemonic words and then have you calculate the last one. So we're saying the next destination is this first screen of the 24 word calculation, right? So right there, the mnemonic length question is the next screen that we're going to go to. So we wrap the view class, like we haven't instantiated this view class. We're just passing the name of the class itself to this destination object. So this is like Python stuff that I didn't even know was possible, a year ago. And it really allowed me to make the code, I think, pretty cool, I'll say. So without even looking at what a destination is, we're returning a destination that's initialized for this specific view class. And it's being returned to, and now we can finally get to the details of the controller. So like we said, just to review, the controller is like our web server. It's managing the overall state, and especially in this case, the user flows from task to task. So the view told us where we need to go next, and then it's done, right? It said, hey, go to door number 5 next, but it leaves it up to the controller to make you go to door number 5. So that's the controller's job. It's been told from the view where you need to go next, and it needs to execute that. So in the controller, we have this start, and it runs this ongoing loop where so I'm going to kind of skip here, but basically this run was us just running that button list view. We just ran the tools menu view. And
Keith, can I just pause you there for a moment? So I'm just working my way back up the hierarchy from tools calc, final word number, words view. That's then returning us to the destination.
No, it's returning. It's returning a destination object to.
Returning a destination object into tools menu view.
Well, no. So tools menu view is creating the next destination based on the user input. And so in this case, let's say the user decided to calculate their 24th word. So the tools menu view will return a destination object that specifies the final word, final num words view as our next destination. And where that goes is it gets returned to the controller. So this
back to controller.
Yeah,
and what line number are we at controller?
233. So this line.
Okay, there's the try catch.
Yeah. So this next destination.run, that is equivalent to us saying tools menu view.run.
Yep.
And I skipped the detail of how it got into the next destination, but we're picking it up mid loop, and we'll get there. So these statements are equivalent for what we just looked at. So tools menu view was told to run, and the controller waits for it to return, and when it returns, it gives us our next destination.
Yep.
Okay. So again, back to the web server analogy, the request was show me the list, the tools menu view. The response it received was my input that said, I want to go enter or have you calculate my final word. Okay. And so
now I understand the analogy. Yep. Thank you.
And all right, so now, and actually I think I got that a little flipped, but whatever. So the next request will be the controller saying, okay, Keith needs to go to that final word view, right? So basically, it knows that my next request request is the same as a destination. So my next request is this calc final word num words view. So now the controller knows what my next request is, and it does a little bit of housekeeping. We're not going to worry about that too much. The housekeeping is primarily around the back stack, which I said was our history. So just like a web browser has the back button and you can go back to your previous pages, SeedSigner UI has the same idea. You can always go back to your previous pages.
But we had to build it.
Exactly, yeah. So we had to maintain our own history stack. So you could be, 10 screens deep into SeedSigner and hit back, and you're just traversing through your back stack. Okay. And we reach the end of the loop and we go back to the beginning of the loop. We have, so this is the beginning of our loop, line 214. Our next destination has already been specified. So these are just two if cases we don't have to worry about here. On each iteration through, I print out the back stack to the terminal. So here we go.
Talk to the debugging, yep.
Yeah, so my back stack. So right now I'm on tools calc final word num words view. If I go back, then I go to my tools menu view. And if I go back again, there's nothing left on the stack. I end up at home.
Got it.
All right, so hide this again. But we know that my next destination is still waiting for me. I'm going to go to this calc 12th, 24th word. And so I say, hey, next destination, run yourself. So I tell the view to run itself. And so that will trigger, and actually, let's see. The destinations, I don't think the code is going to be that useful to look at. It's kind of just, so we have the view class that we passed in, and we say, hey, run yourself. So basically, we're going to instantiate that view class that we passed into it. Because again, remember, we just passed the name of the class, or we kind of passed a reference to the class itself into the destination. So now we're saying, instantiate that view that we passed you. Oh, by the way, inject any arguments. In our case, so far, we haven't seen any arguments that we need to inject into our view. And run yourself. So we're telling the view to run itself. So if we look at our next step here, so our tools, so this was what we said was our next view. So I'm going to go ahead and click in here. So, and same thing. Hey, look, it's a button list screen because it just has to ask, do you want 12 words or 24 words? So just like before, we specify our title, mnemonic length. We create our button data list, which just has these two options, 12 words or 24 words, which I'm just defining right here. And I tell the button list screen, hey, display yourself. And I store the result. So when I finally make a selection down here, my return value will either be 12 words, 24 words, or the back button. So if it's 12 words, then there's some work to do. So if I select 12 words, the first thing we're going to do is initialize a pending mnemonic in our controller's storage. So this is where the controller has to act as our central brain, our central repository of the state of the universe. So, because, like if we're going to enter 12 words, we're going to be bringing up, as you'll see here, the seed mnemonic entry view. Let's take a quick look at that, actually. Is going to be our next destination. It wants to know, what is my current word index? And you default by starting it at 0. So when I click in, this right now that we're looking at on my SeedSigner is the seed mnemonic entry view initialized for the first word in my mnemonic. And then after I make a selection, there we go. Now I'm entering the second word. And so it's going to call this again, but it's just going to increment this for the next index, for the next word, and on until we reach our target size. So the only way to like preserve the mnemonic word that I selected on the first screen that I typed in, I could just keep passing it in. Like I could have a field in here that's like, pending mnemonic, and that's a list of strings, let's say.
Mm-hmm.
And then when I submit my word, let's see, in here somewhere. Here we go. I'm going to do it again. I would have to say, oh, by the way, make sure we pass in pending mnemonic, and it's stored at self.pending mnemonic. Right? I'd have to do all this boilerplate to pass around my mnemonic as I'm building it one word at a time, because this view is just concerned with showing me the keyboard and accepting the one word that I result with, after this data input.
Yes.
And so that's just, it's not the worst thing ever, but and this is a normal Python class. It's not a data class. So I am doing this init stuff. So that would mean I would have to do this stupid thing of self.pending mnemonic equals pending mnemonic. And then down here, pending mnemonic is self.pending mnemonic, right? It's just a lot of like extra crap code that just pollutes things. And that's just for one ongoing input. There are cases with like around the, like imagine the xpub export. When you export your xpub, there's a whole series of questions: single sig or multi-sig, script type, is it, native SegWit or nested SegWit or taproot, what's your coordinator software, on and on and on. It's just a pain in the ass to have to pass those variables on and on to the next screen. Although I think in that case we do it. But, so if we can avoid it, and if it makes sense, we stuff that data in the controller. The controller has this seed storage object in it. And seed storage just has a bunch of random use cases for us. Like, let's see. Yeah, so I can initialize my pending mnemonic. I can update it by adding a new word in there. I can retrieve my pending mnemonic. I can get my fingerprint out of it, blah, blah, blah. So it's just a place to like store things across views, let's say.
And again, that's being passed back up into controller as our web server in air quotes, so that it can keep and hold on to that.
Yeah, this is kind of our version of like a database essentially in the web server world, but it should really be like seed RAM storage, just because for SeedSigner, storage sounds scary. That's like, that's not, or seed, what's the word that SeedSigner, the man, always uses? Not like volatile or, whatever it is, right?
Volatile RAM memory. Yeah.
Yeah. But anyway, so we just stuff our pending mnemonic into the seed storage kind of convenience class that is controlled by, stored within the controller. So the controller has the one and only seed storage instance because, yes, like you said, it is the main brain that's our central hub for the entire SeedSigner code base. Okay, for people still hanging in there, we're getting pretty close to the end of what I wanted to cover. But let me just finish off looking through here. So let's see. Okay. So actually, this is a good example. The seed mnemonic entry view is this keyboard screen, and it's custom, right? Like this is the only, like I can't just throw a keyboard up there. I have to put up a very specific type of keyboard plus this right-hand word list that I can scroll through, up and down, right? So this is a very, very customized screen, very specialized. So whereas the menu views could just use my reusable button list screen without any customization at all, it's just, give us a title and give us the button names. This is completely custom. So in this case, for this view, I don't have a generic screen that I can instantiate to draw all of this. So I had to define a specific seed mnemonic entry screen to assemble all these UI components and handle all of this user input logic of like, oh, when I move over a letter, it has to change the list of candidates, right? This is all very specialized functionality that interacts with my screen object. So in the GUI section, like, yeah, we've got the screen.py for our reusable screen. So let me collapse this. So like your button list screen, your large button screen, QR display. We display a lot of QRs, right? We don't need specialized logic for that. Large icon status screen, warning screen when you're about to do something dangerous, dire warning screen, something really dangerous.
Yes, seen that.
We do have a generic keyboard screen if it's simple enough where you say, hey, the keyboard should have these many rows, these many columns, and these are the characters that belong in the keyboard. But we don't have many cases where we can use just a simple generic keyboard screen. So in that case, we have specific...
Out of interest, Keith, where would you actually need that?
The custom derivation path is just a straight keyboard with limited keys, just the numbers and like M and slash and apostrophe.
Yep.
And then I don't even think the passphrase screen, because it has the side buttons to swap the keyboard layouts between lowercase, uppercase, letters and symbols, or numbers and symbols.
Got it.
All right. Anyway, so when a particular view needs a custom screen built for it, which is not surprising, this happens a lot. We have something like tools screens. So in this case, let's see, what am I looking for? I'm looking for my seed mnemonic entry screen. Okay, so I need to set up my keyboard and my right side match selection UI, right? This up and down word completion UI. So
just help me a second. Which file are you in and what line?
So
it's
this is
too blurry for me to see.
GUI screens, and I'm in seedscreens.py, line 34-ish.
Got it. Thanks.
All right, and so you can see my comment here. I'm setting up the keyboard parameters.
Absolutely, yeah.
The possible alphabet is just the lowercase English characters because we're just typing in mnemonic words.
Yep.
configuring things like the y coordinate, the height, blah, blah, blah. And then I instantiate my keyboard object, and I pass in the values that it needs. And text entry display is an object that goes along with the keyboard. That's the readout on the top. So right now on my SeedSigner, the letters O-N are at the top. That's my text entry display. It's showing back what I've typed on with the keyboard thus far.
Got it.
I got to position that, and then I have to do some work to initialize my current matches. The matches are on the right side of the UI. And then, let's see. Trying to see what... okay, then I'm... it's a little confusing. Matches list highlight, but okay, so this is the... if you notice in my UI on the right here, the selected button word, so onion is selected right now, online is selected right now, that is actually reusing our button class. So that's what's going on line 87. I'm instantiating the center selection line as a button. And then I'm creating my list up button and my list down button that go above and below it. And I position those. And then I have a whole bunch of list of matches. So, and then this screen has to calculate the possible alphabet that it can show based on the user selection. So if I select, let's see, OU, all right, now my possible alphabet has shrunken to just a T. The BIP39 word list only has OUT words. There's no OU anything else. So the screen has to calculate how to change what's visible on the keyboard based on where I'm at with what I've input so far. And then it also has to calculate the possible words to show on the right-hand column, render those possible matches.
And that's what you're using the starts with. Render the possible matches.
And a whole bunch of stuff going on. And then when I run this screen, so just like we saw with managing the user input for, key up, key down, or joystick up, joystick down, now there's other logic for navigating within the keyboard, but then also these right-hand keys, pressing them up and down, or the middle button to select. So all that logic has to be applied in, hundreds of lines of code here.
Yeah.
So, or whatever this was, 200 lines or so. It's most of this file. Yeah. But anyway, the point being is that it's a custom screen that is not reusable because it's only meant to go with this one specific view that has to provide this one specific UI functionality in terms of what it shows to the user, but also the input that it expects from me, the user, and then how it needs to adjust and redraw itself based on all of that interactive user input. And so if you look at SeedSigner GUI screens, you'll see there's a bunch of different custom screens that have to be defined for the different areas of the code. Like within the PSBT area, there's some very specific custom screens. For scanning QRs, there's some custom screens, even settings and tools. So, but the core idea, to go back to this this comparison, right? The controller is managing it's telling the destination, the next destination to run itself, and then receiving the next destination as a result of that. The view is implementing all of the business logic to decide, what what we need to send to the screen so the screen can draw itself, and where the user is going to go at the end of this view, where they're going to go next. The screen marshals all of the UI elements, and it handles all of the logic for the user input. So if I key up and down and around in my keyboard, if I click buttons, the screen has to process all that input and update itself accordingly if necessary. And then it takes advantage whenever it can of our reusable UI components. And so the screen generally is assembled from a series of different components, like buttons, like the top nav, text areas. And then all of those elements know how to draw themselves to get the actual pixel level details out. So if you wanted to build some new functionalities, let's bring this all together. Let's say we're going, let me get out of this, and let me bring this up. All right, let me back up to home. Okay, let's say you wanted to build a new kind of tool option in here. So within the tools menu view, you would add a new option, whatever it is, foo.
Whatever it is.
Yeah. Right.
So it's going to be some kind of explorer of something.
Sure, right. And so then that gets added to our button data list. And so now the button list screen will add, sorry, let me swap back my view here. So here's my fake fourth entry for this screen, or for this view rather. Added it to my list and passed it into my button list screen. So now my tools menu view will add a fourth item to it. And then I would add a fourth elif case. If you click on the foo option, then you're going to go to a new view. And so this new view that we want to do doesn't exist yet. So we would have to create a new foo something view that is derived from view. And at the very least, we need to define a run, and it will do whatever it needs to do. Maybe it shows us a list. Maybe it just, calls up a message.
Pops up a QR or something. Right. Yeah.
Right. And then from there, I mean, the code pattern is pretty in the views is pretty repetitive by design. So you create some screen, whether it's a reusable screen or custom screen. You tell that screen to display itself, and you wait for the end result. You check the end result, and then you route accordingly to your next step, depending on what makes sense. And that's basically the core of how we move around in SeedSigner and how you would build a new page, a new flow into the system. Let me pause there. Any questions?
My one question is, in defining that flow for what the next destination screen is that then set that's set in the if-then statement. If you wanted to roll a dice, or you wanted to draw numbers out of a hat, that kind of thing, that's actually set. The workflow is set. Yes, answering my own question, but the workflow is set in your code as to what the next destination is actually going to be.
Yeah, the view that presented you with that screen and whatever choices were on that screen, it's the view's responsibility to then say, at the end result, what is my next destination based on what the user just selected or how they, whatever they did on that screen. It's the view's responsibility to determine what is their next destination?
So for the example of the XPub export, you've probably got a fairly in-depth set of LFs where we're saying what kind of QR, or what kind of XPub do you want to export, which software are you sending it to, which all of those variables that are going into that.
Yeah.
So that's
right.
handled in that LF type code.
Yes. So like the start of the export XPub process is you have to pick your SIG type, your signature type, whether it's single SIG or multi-SIG. And so the end result of that is if you picked single SIG, we store that selection and then we forward you on to the next question, which is, hey, which script type? And then when we look at script type, that's going to ask you, oh, are you doing native SegWit, nested SegWit, custom derivation path, taproot? Whatever you pick, we're going to store that script type, and then we're going to pass it on to the next step, which is select your coordinator. And on. So you can kind of follow, you can kind of crawl through by just seeing each view, its destination that each destination that each view specifies. And like in this case, if I were to pick custom derivation, well, that's a side step because now I have to go to the custom derivation UI to type in my custom derivation path. And so it produces a different destination, which is the seed export xpub custom derivation view.
Got it.
These are some of these long naming conventions that I talked about. And then when you're done entering your custom derivation view, you can resume and go to the next question, which is xpub coordinator selection. Whereas if you weren't doing a custom derivation, you can skip that and you can go straight to your xpub coordinator selection, or just coordinator selection, I should say. But yeah, so for any view, you can always see where it can lead to next. So like, for example, this one, custom derivation view, it can only go either back, so there's always the back button, or it can move forward to selecting your coordinator. Those are the only options from that screen.
Yes. Got it.
And then things we'll get into later is the settings is a whole other adventure where things like script type you can configure in settings. And if you only have one script type selected, it would be dumb for us to ask, hey, which script type? when the list only has one option. And so we can see here, if our setting for script types has a length of 1, meaning there's only one option to pick from, there is nothing to select. Skip this screen, go straight to our coordinator selection view. And then in some cases, let's see, like after we've picked our coordinator, let's see. Well, anyway, so you get the idea that it's so the settings introduce some more logic in the system, and then if you want to spend some time looking at the controller itself and digging into the backstack, there's some logic where basically anytime you land at the main menu, anytime you land at home, we clear the backstack and we wipe out some of our other temporary values that are sitting around in the controller. Because what we wouldn't want is, like, let's say I just went through a secret operation. I just exported my my mnemonic phrase. I just viewed my 24 words, and now I'm back at home. I wouldn't want someone to be able to pick up my SeedSigner and hit back, and then see my 24 words. Right. So there's certain cases where you reach the end of the road for a flow, and then as you return to the main menu, everything is wiped out, and so it's as if you're starting from scratch again, because we just don't want there are certain back actions we don't want to allow, and so you'll see some logic in the back stack about managing some of these special cases. But again, that's also a deeper topic, and like you'll see throughout the code when something is complicated, like this controller class is super important. This whole loop managing your next destination, right? Like it's so important to understand in order to understand how SeedSigner flows from one view to the next. That I've got a big old comment describing what is happening, right? So this is like, TLDR, I didn't want to watch your 2-hour live stream with Marc. I just read your code comment, So, oops. So this kind of gives you the abbreviated version. And it's mostly kind of in the core classes like the controller, but also I assume if we look at the view base class, yeah, there we go. Here's a wall of text, right? Paragraphs of text explaining how the views work, because this is our base view object that all the other views inherit from. Or our screen, our base screen class. Let's see. Okay, no paragraph of text, but a lot of code comments to explain what are these member variables within our base screen class. Oh, here we go. There's a good couple paragraphs of text. Right. So
what file is that?
That's GUI screens screen.py and then line 97.
Gotcha. Right, so the screen is going to run itself until it returns the final exit input from the user. Yep, that's fine. And it's going to be recalled in a loop until we go through a key up, key down loop, call again.
Yeah, so
raise exception.
So yeah, so there's I think I've done my best to document the code as best that I can in large blocks of text, in small notes here and there. Like line 143, there's a comment that says need to flush the screen. Mostly just because I can't, I'm really slow about reading code. And so I can't just stare at even code that I wrote. I can't stare at it and instantly understand what it's doing. And so I always try to drop these code comments that describe what the next chunk of code is doing, so that when I review, if I need to look back at this, I just read the comments that I wrote as reminders to myself. Yeah. All right. Anything else? I mean, I know we covered a crap ton. I'm sure there are things that I didn't communicate well. Obviously, if people have questions, hit me up on Twitter. I'm at Keith Mukai. It's the goal is just to encourage more developers to take a look at the code, and hopefully this gives you a starting point where you have a sense of oh my God, those GUI components are ridiculous. I hate looking at that code. Hey, the good news is you probably don't have to look in there, right? You just instantiate a button and just don't even worry about what the button code looks like under the hood. And then, experiment, create your own views, create your own new navigation flows from destination to destination. And build cool new features for SeedSigner. I've been the main developer on this since really the beginning of the year, but I think it would be ideal if this code base had less of my imprint on it and more contributions from other people. And that's really the goal, so that people can come in and add amazing new features that I wouldn't have thought of, or I didn't have time to build, or bug fixes like Marc already knows a UI bug that he wants to tweak. Yeah, that's the goal, just to get you started so you don't have to just stare at every single line of code in this code base. You can just kind of jump to the parts that matter.
Keith, one last question before we close is, if I make an edit to a file, my rsync runs, does the SeedSigner see that change immediately, or do I need to restart restart the app?
Yeah, you have to restart.
Okay. So the checking of what I did is print statements, and then seeing whether the flow worked, etc. And then I've got a batch file already just to kick off the restart, copy over, and then hit the restart.
Yeah, so here, I just made my change of adding this nonsense foo option to the tools menu view. So I'm going to stop my SeedSigner, restart it. And this run.sh is just that convenience script that I added.
I've got one of those as well.
All right, so my SeedSigner is coming back up. Let me highlight this. Kuma is pawing at me. Ouch! Oh, her claws are so sharp. Go to tools. Hey, there's foo right there.
And there's foo.
Yeah.
Okay, great.
But now
that is exactly what I did yesterday. I was just wondering whether there was a alternative way of doing it.
Yeah, and then because I didn't wire up in an else case for foo, if I click it, it's, not.
Right, because it's going to fall back to that. There
right,
we
because
go. And it's true, foo is not yet implemented.
Yeah, because what happened was my view ended up returning nothing because there was no if case that handled the foo option. So this view just exited without returning anything, and then the controller has a check for basically if here it is.
All of the underlying ones have failed.
Yeah, so if
that's what it's going to return.
Yeah, if destination is none, show the not yet implemented view, and that's what we're staring at now.
Yeah, beautiful. Wow, that was a really informative session. Thank you, Keith.
Yeah, I mean, that was I worry that it was still way too much for anyone to really reasonably digest, but at least because the live stream will be archived, I will set. I'll do my best to set chapter timestamps throughout this discussion to kind of like how it broke up, like what topics we focused on when. So hopefully people that are interested can go back and view just the chunks that are helpful. And then as you become more familiar with SeedSigner, if you come back and view more of this, more and more of it will start to click in. But I'm completely sure that if somebody just watched this, start to finish as a first entry point to the code, it's still going to be like complicated and overwhelming. But again, hopefully it just gives you a little bit of a starting point, and then you'll be able to kind of accelerate faster from there.
The more I practice, the better I get.
S10S BTC says, well done, great top level overview. Thank you for saying well done. I think with practice, this could be like 80,000 times more clear and useful. But this is also why I like doing this as a live stream, because getting this right and editing it together would just take an eternity, and we ain't got time for that. So we do the best we can live in the moment. And then we'll clean it up afterwards by just asking questions on Twitter or Telegram. Hop in the Telegram group. Oh, I forgot my shill. My shill. Shoot us some sats if this was useful and you made it through, 2 hours worth, the three of you that are left, if anyone, this is the lnurl link, and my there we go, my PayNym, restless night.
Your new PayNym.
Yep.
Very nice.
Shoot some sats over if you've got the sats to spare. I'm currently working as a volunteer. I'm back to being a volunteer on SeedSigner, and I'm still loving every minute of it, but ain't nothing paying the bills doing this.
Yep. Yep.
All right. Well,
Right.
I will
Thank you very much.
Yes. Thank you, Marc, and thank you all, everyone out there, and we will